Welcome back to our video series about MRM cubed workflows for residue quantitation. We've given you some background on the benefits of using MRM cubed. Now we want to show you how you can easily upgrade your MRM acquisition method to capture MRM cubed data for your compound. For our example compound malathion, where we identified second-generation product ions 71 and 81, here is how we can create an acquisition method with these MRM cubed transitions. In Analyst software, we start by opening our MRM acquisition method for malathion. The benefit of using our already pre-configured acquisition method is that our LC conditions and our MS source conditions are already set up, so no additional changes to those parameters are needed. To modify our MRM experiment to change it to an MRM cubed or MS to the third experiment, we first will change the scan type from MRM to MS3. When we do this, the precursor ion and product ion information from our MRM method, in this case, precursor ion 331 and product ion 99, are automatically filled in as the first precursor and second precursor for our MRM cube transitions. We now need to add in our two third-generation product ions, or ions 71 and 81. We want to be sure the center width box is checked, and we will enter the product ion mass as a center with a 2 Dalton width. We are using a 2 Dalton scan width because we're not scanning a wide mass range, but just focused on the mass associated with our selected ions. We also need to set the scan rate for the experiment. In this case, we set the scan rate to 10,000 Daltons per second, which gives us a good cycle time to ensure we capture enough points across our peak to perform quantitation. The scan rate can be adjusted as needed based on your chromatography and the fragment masses you are detecting. The dynamic fill time setting on the Q-trap system also plays an important role when performing an MRM cubed experiment. The dynamic fill time is the time allowed for the trap to fill with ions before they are scanned out for detection. If there is a high ion count, a shorter fill time is activated, while if there is a low ion count, a longer fill time is activated. Just as in an EPI experiment, DFT should always be activated in an MRM cubed experiment. Finally, we will need to adjust the energy applied in the ion trap to excite and dissociate your fragment to produce your second-generation fragments. To adjust this, go to Edit Parameters and select the Compound tab. The Excitation Energy, AF2, is typically optimized when we are scanning our compound for its unique MRM cube transitions. For malathion, we will use a setting of 0.1. As you can see, once you know the second-generation ions you want to monitor for your compound, creating an MRM cubed acquisition experiment can be an easy upgrade from your pre-existing MRM acquisition method. If you want to learn more about setting up MRM cubed for your routine methods, submit your questions or comments to our expert support team at www.abscience.com/qtrap for food testing.